If you sit there and you animate something from start to finish, you put it in your game and it doesn't look good, you're gonna feel really disheartened because you spent all that time making something and you weren't able to get it where it needed to be. And once you're at that point, what do? Do you start again? Do you start playing with individual pixels on specific frames? Then you've got to make those details, consistent across all the frames. It's a very tedious process, and I know exactly what it's like. I've been through that. Hey guys, welcome back to another tutorial. Today we're going to be covering platformer jumps, and this is one of those animations that is really heavily bound to the mechanical side of game development. So it's not going to be one where we can go straight into Aseprite. I'll be talking you through how I implemented the jump, but I won't be building it from scratch because this is still an animation tutorial. So let's cover a bit of background information first before we get too far into it. Platformer jumps. Jumping states in games have evolved a long way. There are, at this stage, if you're doing pixel art, a lot of different interpretations and implementations of how you can actually build the animation, what it's made out of, how the states work. So I'm going to talk through those now. In the most primitive games that have any kind of platforming, the jumping animation is really just one sprite. It's just this airborne state. So in Super Mario Brothers, this is all we get. Super Mario, he's jumping, that's it. There are other games on the NES that have jumping animations, such as this one here from Ninja Gaiden. In this case, it's just a jump loop. So it doesn't really care about what we're doing, as long as we're not on the ground, as long as we're airborne, this animation is playing, and it's a forward flip, if you can see here. In the SNES, we got a little more memory, a bit more fidelity, and games like Super Mario World did a lot more with their jumping. In this case, we've got a rise state and a fall state. And again, for this example, it's just one sprite per state. So it's either this or it's that, depending on what's happening, going up or going down. And those are bound to the Y velocity, right? It's just bound to the speed that your character is moving in the up-down direction. When we look at this, we're sort of heading towards something which is more fidelity on the y-axis. And you can take this, so in this case we've got like one animation because we're in the air, then we've got two animations, right? One going up, one going down, or two sprites. But what if we were to plot this out into many, many frames? So depending on your y velocity, you show this frame or this frame or this frame, and then depending on your negative y velocity, you start showing frames going down. In this way, we're not really playing an animation so much as polling the velocity and picking a frame. And assuming your character is jumping through the air, it will actually play this as an animation just by virtue of your character's velocity changing over time. Most of the animations that we do when we're doing pixel art, we play them based on time. We just say, here's frame 1, after this many milliseconds, play frame 2. In this case, we're actually playing the animation based on velocity. And it will go through the whole sprite sheet the same way, but it's going to be much more dynamic to what's happening on screen. And there is some precedent for this as well. So going back to Super Mario World, the example that we have is the cape. If you look at the cape, when we're in the air, you can see there are a bunch of different frames here. We have different frames depending on how fast in the up-down dimension Mario is moving. If he's moving really, really far up, the cape is being pulled downwards. As he levels out, the cape levels out. And as he starts falling, the cape starts, flying up. We can see this. I've actually got this loaded into Aseprite here. As we go up, you can see the cape is pulling downwards. And then as we fall, the cape flies upwards. After Mario hits a certain velocity in the negative direction, the actual cape does loop. So it's almost like we reserve the last few frames and we just loop through them based on like modulo, depending on how fast we're moving. And that will create some like flapping in the wind. Allow me to show you the same system at play in Insignia. I'm going to do a jump and pause it. Here we see Armin is in his maximum upward velocity state. And as we start to fall, we can see his jacket start rising up. For those of you who are inclined, I'm going to show you what this code looks like in Insignia. So I've just shown you the animation. This is the only, it's 2 lines of code spread out over 5. And this is all it really is. We find the air index, which is the sprite index in the array for the sprite that we want to use. And then we just set the animation to that sprite. Here, you're going to have your array that looks like this. It's your sprite sheet. And I've got each of my frames saved in an array. The array then by default has an index or indices, and we can set the current sprite to one of these frames depending on our velocity. It's exactly as I described it. So the way this works is we just take a number, which is our velocity on the y-axis, and we map that number from the highest speed that we could possibly be moving at to the lowest speed that we could possibly be moving at. So maximum velocity in the positive direction versus the negative direction. And we map that from the first sprite to the last sprite. That's it. I also clamp the value. That's just to help it not go out of bounds. So if you are moving really, really fast, we don't want to be sampling from, frame 7 if there's no 7th frame. For those of you who know how to code, that should get you most of the way there. So the next question is, what does this look like and how do we prototype an animation against this functionality? My recommendation for you, if you're writing your game and you don't have this already built in yet, is to just get the jump behaving how you want it to behave, right? So we haven't really described what the jump arc looks like, and this is something that can be developed in a bunch of different ways. The simplest thing to do is to just, when the player presses the jump button, set the velocity to a direction that's going up, and then just let gravity sort the rest out. That is the most basic way to handle this kind of thing. I have a much more complicated setup where I have actual velocity curves that get played through, and I have multiple curves depending on if you release the button early, so you can do like a short hop versus a full jump, and I'm not really beholden to gravity, so if I do a full jump, we hang in the air a little bit longer. These are super duper niche things that you don't really need to think about, but all you need to do is get to the point where you have your little white box for your character or your idle animation just, jumping physically on screen the way you want. From this point, you want to start mapping your sprite to your jump. And the tricky thing about this process is before it's in the game, there's no real way to tell how this animation is going to map to it, right? Like, how do we know what frames to draw here, right? This isn't really intuitive as an animator because I'm not drawing something jumping. This sort of just looks like a bunch of different states, that I have to imagine, or we're moving fast up or slow down or whatever it is. There are a couple of techniques that you can use to actually bring this back into a more intuitive space. And I'm going to go through them very quickly. If you have some physical object and you fire it out of a cannon, the actual curve that it makes will be symmetrical. We can take advantage of this and take like a very scientific approach and treat each of these points as frames and animate all the frames. If you want something that's intuitive, then you can follow this process by literally, drawing on a bunch of different frames. Let's say we want to split this up so every second dot will be a frame. So, we start here. And say we want to dedicate 10 frames to this. That's quite a lot. You could do a lot fewer. It doesn't really matter how many frames. So we can go frame 1, frame 2, frame 3, frame 4, frame 5, 6, 7, 8, 9. So you can do something like this, where you actually plot out the animation. This is an approximation of what's going to be happening in your game, right? It's not actually the jump arc. And so This is easy to do because you can simply take your animation, you can draw your character on each of the frames, you can stabilize it, so move your character to the same position on all the frames until you have something that looks like this, and it will work in the game. So here's one I prepared earlier. It's a very simple setup, and it allows us to really analyze what's going on in a jump. Right, we can look at what's happening with the hands and arms at different stages. And it's, like I said, it's quite clinical, but it's not super applicable necessarily to your game. So it will definitely work, but you'll have to do some tweaking. Once you've got this, you can lock it to the center. So just dragging your character to like the same point on the frame, and then we get something that looks like this. That can be used as your sprite sheet. So that's method one. The second method involves actually screen capturing your game and animating over that. And this is why I recommend implementing the actual jump first. So if your mechanics are done, then you know the arc of your character, you know how many frames to dedicate to which part, because you know how long each phase lasts, right? If your character jumps only this high, you may want to decide on a different set of frames than if your character jumps this high. You know, is your character leaping or are they just stepping? You know, what's the actual dynamic that you want to have? And oftentimes, you know, it's good practice to actually define the mechanics before you even determine the character's traits, because you may find that, you know, the game that you've made is one where the character is very small and jumps very, very high. So maybe it makes more sense for that character to be a flea as opposed to, you know, a big lumbering action dude. You know, if he's only this big and he jumps this high, does that make sense? Who knows? Up to you. But definitely creative choices can come second with this kind of very technical animation. What I'm going to do is I'm going to bring this back down to a resolution that is exact. So full jump forward. Stop recording. I'm just going through an online converter, and I'm going to make it into a GIF, which I can then drag into Aseprite. We drop it in, and we get a really ugly looking GIF, super compressed. That's our jump. So here we have now 40 frames of our jump. And these are pixel accurate, even though this looks kind of weird. If we take Armin here, he's the exact same size. So even if he's not very clear, he is the same size. It's the same scale. Just to confirm the way that I did that, I made sure that when I recorded the game, I have it set to 1x, and I have the actual screen resolution set to the native resolution of the game. So in my case, it's 640 by 360, and I'm at 1x, and I'm just recording it at 1x. Otherwise, this will be bigger than your actual sprite. You'll need to scale it down. We want to start from here, and we want to end the second we hit the ground. So what we can do is we can start dividing this up. There are 36 frames here. So we save one, delete two, save one, delete two, save one, delete two. I'm going to mark the ones that I want to delete. So click, click, nothing, click, click, nothing. There we go. So I can delete these ones, and that's our animation. Cool. So this is obviously going to be, we need to set this to the right frame rate. So 1000 divided by 60. What is it? No, it is 16 milliseconds. Multiply that by 3. So it's 16 times 3. I deleted everything except every third frame, which means I multiply by 3. That makes sense. So we have 12 frames now. And I think it would be a good idea to at least take the action here and compress the frame. So we've got all of this extra stuff that we don't care about. Let's crop the canvas so that we don't have to worry about all that stuff. The next thing I'm going to do is, I don't really want to be influenced by what's here. It's a bit noisy. It might sway my interpretation of what's going on. So I'm going to just take the information that I care about and I'm going to remove everything else. So that means taking maybe the position of where I think the floor should be, and then we're going to take the position of the character's head or chest or something that's going to be in the same spot the whole time. Wherever your character's transform is, that's the anchor point that we're going to be using here. What I'm going to do is take the just a color that's very clear, and I'm just going to draw like a circle that represents where that is. And here it's quite simple because the very top of this pink circle is going to be right there. So this center of the chest is perfect. So now this lets me very quickly just place this here and here, here. And if you're doing this at the start of your game, what you'll be animating over right now is a box. So you should have a very simple, you know, non-animated sprite. So now we can actually remove this. And what do we get? Look at that. That's really cool, right? Now we can actually see, oh, that's what we're animating. There's our jump. It's exactly mapped to what happens in the game. It's frame perfect. We have exactly 12 frames and we peak right around the middle. So I have no problems now using this for my game. We're at the point where you've already designed your character. You have maybe an idle animation and a run animation, and now you're doing jumping. So you sort of know what the character looks like. We're gonna take our character and we're just gonna paste him in here on his own layer. So now I know how tall this character is. I know where the center of mass is on all of the frames. It's just up to me to animate. Since I'm gonna be using a stationary jump, I think one of the things that's probably gonna be the most robust is to keep your character quite compressed when they're in the air. If the character is biased in a direction when they jump, it's gonna be really hard to use that on both kinds of jump, one with momentum that's forward and one that's stationary. So instead, I'm just going to make something that's stationary that works for both. And like I said, I'm gonna do that by compressing so the character's kind of like almost like a cannonball when you're in the air. First thing I wanna do is take this and give it a name. This is chest. And I want to basically like start filling in the other stuff. So let's take the head as well. And we can plot the head in the same spot. Doesn't have to be perfect for now. Just plot it where you want it. We already decided where the chest was relative to the head, so we kind of already know where that is. My goal is to give myself space to change this stuff, but I can't change it if it's not on the canvas. So that's what we're gonna do now. Make sure it's on the canvas. Let's get some legs in here as well. I like to name my layers based on their position relative to the camera. So in this case, front leg is closer to us, closer to the camera. That way, if you flip the character, it's not confused about whether it's the left leg or the right leg. Because we know where the hips are relative to the character's chest, we know where the top of the leg will be for every frame already. The thing that's not defined yet is the knee and the foot. So I'm gonna define the lower part of the leg first, and then just fill in the gaps when I do the upper part. On this frame, we've just leapt off the ground. It's hard for me to like intuit exactly what this should look like on this frame, right? I don't think anyone just with their intuition is gonna know exactly what this looks like. But if you put something in the frame and you animate it, and then you watch it, it's very easy to see that it's wrong. And usually you'll get a pretty good indication of how to fix it. So again, just get stuff on the canvas. This is looking a little fast for me. I want to be able to watch it a bit slower, so I'm going to make this slower. So I think what I don't like is that during the entire animation, the legs are pretty much in the same spot. So what I'm going to do is stretch them out on these lower frames and then bring them up later. The other thing is, I think it would be nice to have the legs really tuck up under. And you know what? I think having the legs swing back as we're coming up would be kind of interesting. So there's a bit of a cycle going on. So maybe we start, you know, here. Next frame we come up. Next frame we swing back. Back more. And then we're here. And then we swing it forward. Notice that I'm really looking to getting it to feel correct on a per limb basis. I'm doing the whole animation for one limb at a time. That's starting to look like something. I think the leg swinging back and then coming forward was a good move. Do it like this, swing it back forward a little bit more. And the real beauty of doing this on separate layers is you can just press V and drag them around, right? If it's just a positional change that you're doing, you don't need to redraw it. You could just drag it. Now it's got some real flow to it. It's not right yet, but it definitely captures something that I wanted to capture, which was that compression, right? We're seeing the body feel really tall here and really compressed here. So at the very least, I'm moving in a direction that's positive relative to like where I was 10 minutes ago, because they didn't have anything on the canvas 10 minutes ago. It's starting to feel like something now. Now we've got some dynamism going. Like I said, we're going to be using this same animation for the static jump and the forward jump. So even if we're jumping in a direct vertical line, I want to expect that the character has a little bit of forward momentum, because most of the time the player will have a little bit of forward momentum. So in this case, having the chest protrude forward and the head go back feels like we're being propelled that way. You can see that, you know, if I gave the character a nice big set of wings, I feel like that would make sense, right? We're being like thrust forward. And when you jump, you know, if it's a powerful jump, feeling catapulted forward, I feel like this is sort of like got the right energy. We can see here, I've got the head tilting back. What that's doing is kind of doing two things. One is expressing the power of the jump. You know, the chest is forward, the head's going back. And two, it's actually giving us an indication of where the character's looking. So we're looking up as we jump up. And then as we start coming down, the character's leaning over and looking down. I think that makes it look a little more natural and alive. So we have this animation, and we don't know yet if it's going to look good in the game, but we really do want to know if we're in the right direction and if this is going to work at all as soon as possible. So what I recommend doing, and this is a little bit tedious, but I think it's good practice, is compress this down so that it's stable and then put it in the game. The way we do that is pretty straightforward. I'm going to take all of these layers. One way I like to do it is to make a new group, and then if you just copy the group, you can make a new file, make a bunch of frames, and then I think you can just paste the group. Paste. Effectively, all I do is flatten visible, and then canvas size, let's flatten back down to about here. And all we want to do is just make sure that the pink is in the exact same spot every frame. So I'm just going to put it right at the junction of the second box on both frames. So just literally like this every time. So now it's more or less stable. We can take this, we can bring it down into a 64 by 64 box, and we can export that. It's a little tedious, but if you want to do a good job, that's how I do it. This we can just export with Control E. If you're in Aseprite, you can make a horizontal strip out of it, no problem, export it. And if you've saved your file inside of Unity, then you should just be able to search for it and it'll be there. So here is Arm and Jump 2. There's our sprite. If you go to your sprite options, make it multiple, you can apply that and then slice it. There it is. Apply. And now we're in business. We have all our sprites. So I'm going to go to my air control script, and I'm just going to change this to jump 2. And that's, for me, that's as complicated as that is. So now we can test it. I think the head is a little dramatic. The feet aren't so bad, but the head launching is definitely too much. The crazy thing about this now is that we can actually, whenever we update this file, which we will be doing whenever we update this. We can always just save it and it'll auto update inside of Unity so we can see these changes in real time. Let's do some arms. Let's put a background in here so that we don't get too lost. So all I'm doing with this is I have my frame, on this layer, right click, link cells. And now the background's on every frame. That actually came out quite well. I think I want this to be a little more dramatic. Doesn't feel that bad. Let's go to the back leg. I think I want the legs to swap. So maybe we'll keep this down at first. Kind of feels backwards almost. Yeah, I think the frame itself is a little weird, but the arms are really, really right. Okay, this is going to be probably the last time I do this, just because I think it's quite tedious. But I wanted to get the basic gesture down. Cool. That's starting to look really good. That's great. I especially love the frames as we go off the wall jump. They feel really powerful, like he's really pushing away from the wall. That's that head leaning back on the first few frames. It works really well here. I feel like we're at a stage where what's in the game, like the actual gross motion, is accurate to the jump. So it's probably not worth staying in the unstabilized version. The reason why we can justify that is because everything that's already in the animation already tells us what's happening with the motion. So the hair, where that should be, we can base that off what's happening with the legs. Same thing with the cape. In fact, maybe we'll just do the coat now before we move forward. And maybe actually we'll also do the torso. I'm actually trying to start with the hips forward and swing them back. You can see the bottom of this purple bit as we jump. It's forward in front of the chest, and then as we come back down, it's behind the chest. Nice. And the jacket actually what I'll do is I'll just think about the bottom hem, this part here, and that'll be like the rough animation. And it's going to fall roughly in the same fashion as the arms. Let's bring it up higher and higher and higher and higher. And I kind of want it to swing outward as we climb up and then come back inward. Nice. So we can do like the rest of the jacket by just connecting this line to the shoulder, which is right under the head. Nice. I think when I look at it, there's one thing that I'm not 100% on, and it's just when the head leans forward. I feel like you shouldn't really have to look too far forward on these frames. I also think the coat is a little bit too high. Now we have the entire animation with all of its layers. So from here we can do all of the extra work and detail that we want to do. And we don't really need this animation anymore. It's a lot faster to be working back and forth from here. We've got that vision, we've got it functional. We just need to, continue on as we've been doing. And you can start to see some of the imperfections here. We should be able to track the details in a very consistent way all the way. So if you look, the pink piece here, we should be able to watch it move with velocity. All right, so there, not quite consistent. And that's a big jump there between these two frames. That means that this frame, it needs to be higher and one back, and then we can start reflecting it to look like that. Cool. And now that we're working with this size, we can easily just export this into the game and check it out and make changes very quickly. That's ultimately the goal. The goal is to be in a position where you can make very, very quick changes and watch them in the game and make informed decisions based on that. Because this is the target, right? This is where it's going. And I don't want Armin's face to be obscured by his hand here. So we're just being very careful about where we put our arms. I think that's the one there that I want to use. All right. So, shall we get some more limbs in here? And like I said, it's kind of like connecting the dots. Once you have the knee and the torso, you just fill in the blank. It's not that difficult. So I'm really happy with where this is going. We've got a really nice set of, an extension of the limbs, compression as we come up high. Like if we watch as we come down, the legs come down to brace. Arms go up, and then we go into the crouch. I mean, to me, that's pretty good. And this is where you want to be. You really want to be in a spot where you can prototype in the game and make those micro adjustments very quickly back and forth. If you sit there and you animate something from start to finish, you put it in your game and it doesn't look good, you're going to feel really disheartened because you spent all that time making something and you weren't able to get it where it needed to be. And once you're at that point, what do? Do you start again? Do you start playing with individual pixels on specific frames? Then you've got to make those details, consistent across all the frames. It's a very tedious process, and I know exactly what it's like. I've been through that. So, this process, although it's tedious at the beginning, it saves you a lot of tedium in the long run, because once we've got this right, once we feel like we know exactly what jump we've got, and we're happy with it, we can start detailing it, and it won't ever not be as good structurally as it is now, because the details aren't structural. I'm still not 100% with some of these things. So like, for example, like the way the red leg comes up, something's not quite right about it. Maybe even here. Don't tunnel vision too deep. So look at the whole thing as a whole picture and just think, does this look right? Does that look right? Maybe this could be a little taller here and a little further up. Now it's looking a lot smoother. And you can refine this as long as you want. I mean, it might be time to move on for us. For the sake of the tutorial, I'm going to move forward into the detail phase. Okay, so you've seen this process before, but we'll do it again as we do. I'm basically just going to take everything that we've got here and map it to the correct colors as they should be. The shortcut is Shift R, and that gets you this. I pick the color that I want for the pants, and I find and replace pants. And you actually just click the layer if you want. So like here, I'm just going to click whatever this is, back leg lower. If you click this so that you get the yellow borders around the name, then you can just do it, blanket like this. The arms are going to swing back while the knees go forward, right? Oh, behind.
Up my legs, extend them completely, slightly bent, and then absorb the impact with my legs.
Damn, that was pretty good. He's got some technique. So this was too dramatic then. And this I think is too stiff. The really difficult thing about doing this kind of animation for hair specifically is in real life, you know, hair just flops everywhere. But it's part of this character's identity that he has a fringe coming down the front of his face. That's just like, if you don't see that, then you don't see him. So it's really, really difficult to, work in this context where we want to show the velocity. We want to show like all of this craziness that's happening without losing the identity of the character. Okay, so now's the time, once I'm at this point, I start thinking about any other major aspects of the character's design that contribute to like core lines in the contrast of the character. So in this case, like the belt and then the cuffs on the top of the boots, maybe even the collar here, the separation between major materials. That's what I think about next. So I can take this and just draw it as I like. And this is just important because it's such a dark piece of the sprite that if it's wobbling around everywhere, if you don't consider it in an entire loop on its own, then it will look really odd. It won't look fluid. So now it looks nice and consistent. And we can work the buckle in. There we go, looking really good. See, once you've got certain details like that, things that really ground the character, it becomes much easier to see it against all the other animations. So now we can really see if there's anything particularly off-putting about like some of the proportions, or, you know, are his legs too long or is his head too big? Those are things we can really see clearly now that we've gone through those structural stages. Right? We've made sure that the attitude is right, the physics are right. We've started coloring things correctly. We've started adding in those major contrast points. The next thing from here, once we're happy with that, is to do shading and then detail. That's it. So watching those details as we animate is a really, really good way of spotting early if something's going to be smooth or not. So if we watch this toe, as we move up, you can see this is clear. But then, we're going forward and then we go up. So we've drawn this shape with the toe that looks like this, and that's not smooth. We want something more like this. So instead, I might bring this further over this way. Getting pretty close now. This part takes seriously a lot less time than it used to for me. I mean, I've done, God knows how many animations for Armin at this point, but yeah, it definitely takes a lot less time than it used to. So there's not much left now. That was pretty quick. I'm moving towards simpler shapes for Armin. I mean, having him be this detailed, you know, like, what does this fold on the pant do, you know, for him? I mean, it does, it adds something, but like, is it really worth, you know, thinking about these pixels, 1, 2, 3, 4, on every frame of every animation that he's on? You know, if it's gonna take an extra 20% of my time, might not be worth it. So this has been the jump tutorial. From here, obviously, you would be animating the details to your heart's content, but I've taken you through the basics, I've taken you through the process, I've taken you through the details and with examples. So happy animating, and I'll see you in the next one. Hey pal, thanks for watching, and thanks most especially to the patrons and Twitch subs who support this channel and my game dev project Insignia. To find out more, click the links in the description below. And if you like this video, tell YouTube by clicking the like button, and then YouTube will tell me, and then I'll make more videos. That's nice.